Okay, we're going to get started. Hi, everybody, and a very warm welcome to today's webinar. My name is Aarti Holla-Maini, and I'm Secretary General of ESOA, which represents the interests of 21 global and regional satellite operators. Today's event is the fourth in a series of ESOA webinars, which we have themed Global Challenges, Satellite Answers. And we're very grateful to 3GPP, where ESOA is market representation partner for the global satellite industry, for endorsing our event today. I want to start by introducing you to our panelists. Jonathan Beavon, Senior Director of the Product Group at Inmarsat. Hi, Jonathan.
Hello.
Hi, Jonathan. I-Kang, Director of Standard Strategy at Mediatek. Hi, I-Kang.
Hi, it's I-Kang here.
And Thierry Bérisot, IoT and Telecoms Director at Novamint. Hi, Thierry.
Hi there.
So today we're going to talk about how satellite can expand the opportunity for NB-IoT for global applications like asset tracking. I would invite you to share your questions on the chat, and we will get to them during the discussion. We would also like to know who you are, so please rename yourselves if you can with your company affiliation so that we can see who's with us. We're going to be recording today's session, and we will make it available on our YouTube channel very soon. So let's start by understanding why asset tracking is important. Our world depends on global trade, and so much of what we buy as consumers has either been made, assembled, or grown in another country from that where we live. That reliance has resulted in consumers expecting to receive what they want when they want. And in turn, that puts enormous pressure on the supply chain to be efficient, to be on time, and to deliver goods in perfect condition. It doesn't matter whether those goods are high-value assets or perishable or otherwise. They all contribute to the massive IoT market, which is growing, but which also includes billions of devices, for example, for asset tracking, that are not addressed yet. There are different reasons for that. A lack of solutions with global coverage, no ease of deployment, power consumption, and no global standard ecosystem that meets vertical's expectations as yet. So against that background, let's jump into today's discussion. Jonathan, tell us, why is Inmarsat testing a 3GPP standard over satellite? And I-Kang, who is Mediatek and why do you care about satellite? The floor is yours.
Thank you. So thanks to ESOA and 3GPP for this opportunity to talk to everybody. So why is Inmarsat interested in NB-IoT over satellite and 3GPP in general? So it's very important for us to look at mobile networking technology because we're a mobile satellite company, and we think the standardization efforts in this area point to the future of a cooperation between satellite and MNOs in the terrestrial sense, and combining the two worlds together to give ubiquitous coverage. So that's really why Inmarsat are interested in this. So I-Kang.
Yes, from Mediatek perspective, we understand also there's a very good coverage for the cellular IoT today, but most of the base stations are still installed based on the human distribution. And from this like asset tracking perspective, there is always somewhere that is difficult to install the base station, and satellite could be a very good complement to combine with the cellular coverage that can offer the truly like a ubiquitous coverage around the world. And at the meantime, we also see the if we can have a two ecosystem working together, and we can enlarge the economy of scale, and that should be beneficial to both cellular and satellite ecosystem. So we share the vision by Jonathan, and we think that could be mutually beneficial. Thank you.
So I was just looking at who was attending and trying to work out what the audience was. So some of you might not know Inmarsat, and some of you might not know Mediatek. So I'm going to run through very quickly who Inmarsat is, and then I-Kang will run through that, and then we'll get to our proof of concept of NB-IoT over satellite and describe that. So Inmarsat is a pioneering satellite company. We've been in existence for 40 years, and we started with safety services in the maritime market. So we have a very full fleet, and we operate in both L-band and K-band. And we're quite unique in the satellite world because we're a mobile satellite company. So our technology mirrors a lot of what goes on in the mobile world. So we have spot beams like you would have cell structure in mobile telecommunications. We are also global, and we also have global coverage in both L-band and K-band, which is important for reliable and high bandwidth services, so VSAT services. So that's really quite unique amongst satellite operators, being a mobile, global, and having a choice of satellite bands to choose from. And right now we are very dominant in the maritime space and also in aviation, both for safety services in the cockpit and also for providing broadband in the cabin. And we also supply civil government and also military applications. And most relevant to this conversation is our enterprise group, which actually does quite a lot of work in asset tracking and IoT applications, particularly in places which are either moving, so for example on trains or ships, or things that are in remote areas such as some large-scale agriculture or some mining operations or oil and gas operations as well. So those are the markets that we operate in. So that was a quick overview of Inmarsat. So now, who is Mediatek?
Yeah, the Mediatek is actually a group of company, including the Mediatek Corporation, also few like a subsidiary company who do the different style of the chipset. And as you may know, Taiwan is quite like a major semiconductor supplying vendor in the world. And there are many chipset company in Taiwan, also a very huge foundry supplier here. So after like 20 years growing, and Mediatek is already grow from one individual chipset supplier and expand to the broader coverage to the entire supply chain. And if you go to next page, and then so far the Mediatek group is the world #4 fabless IC design company in the world. So we got last year we have 8 billion revenue, and this year should go higher. And if you include in the kind of semiconductor company with the foundry, then we are fabless, but we are still number 13. So many people may not know the Mediatek product is actually already around you everywhere, like almost I think more than 70% of the digital TV. So if you open the TV on your home, then you will find Mediatek chipsets actually there, and all the Blu-ray, DVD. So that's why we call that Mediatek. We start from multimedia, and then we go to the mobile computing. So for the smartphone, we are now the #2 in the world. And for other wireless communication, we also have a very broad coverage in the market. So in the that's why Mediatek have a very long experience in this consumer space. So that's why it's an interesting combination that we work with Inmarsat, because we can bring the view that how this satellite link might be useful to the consumer application in the future. That is also the area we are trying to exploring. So hopefully with that background, the Mediatek can contribute to both ecosystem to find and enable more market space. So Jonathan?
Okay, thank you. So that was just to, for those of you who didn't know Inmarsat and Mediatek, just to let you know who we were. So as we said at the beginning, Inmarsat is now looking at 3GPP specifications. So we decided to operator proof of concept to prove that NB-IoT could actually work over satellite. What we found, and we're very pleased that ESOA and 3GPP have actually put what they call non-terrestrial networks, so satellite networks and also other networks that may come from high altitude platforms such as balloons. They put other networks other than terrestrial networks on the agenda for 3GPP. So we believe that that's very good because the promise of 5G really does depend on having ubiquitous coverage, and satellite can fill many of the areas where other terrestrial networks can't reach. And we think that's probably essential for delivering the 5G vision and delivering all of the promised large economic benefits. So that's why we're very pleased to see this kind of on the agenda for 3GPP. Inmarsat has one of its networks in the L band is from our Inmarsat 4 satellite. So our L band network is a geo satellite network that covers the whole of the world, and because it's L band, it's very well suited to small IoT devices receiving IoT signals from satellite. So it's very robust. It's not subject to any rain fade, and also it can work with very small and low-cost antennas, and so if you combine that with low-cost NB-IoT chipsets, you end up with quite an attractive service. So that's why we decided to do an evaluation of the standard as it stands right now for NB-IoT. So then we realized that we needed to work with a chip vendor. So we then decided to work with Mediatek to set up a trial setup and to test over the air. So I-Kang, I don't know if you'd like to talk about the end-to-end test that we did.
Yeah, I think regarding to the technical content, I think you can see from our actually a lot of proposal has been submitted to the 3GPP regarding to the IoT NTN study item. And then basically the implementation in this trial system is basically follow what you have been seeing in the 3GPP proposal. So it's basically try to prove the feasibility that the satellite by using the consumer grade of the NB-IoT device, and with also some chipset modification, then we can indeed really reach the receiver at the satellite, which is 35K kilometers away from the Earth, and then successfully get a data delivered all the way back to the ground station and successfully decode by the base station and vice versa. So we although the 3GPP study do have the link budget analysis, but the people will not believe that is true until they see that really happens. So that is one motivation we want to show, that also it sounds crazy from the cellular vendor perspective, because the base station usually is just a kilometer away from our device. But in this trial, we do prove that, yeah, it is indeed feasible. Those link budget number is actually true. That is the first point. And the second point we try to prove is because there's very long propagation delay, so the NRNTN already study the necessary adaptation to enable this radio link. And basically, we prove that is indeed workable. Of course, we are using the NB-IoT as an experiment tool, but that proves those concepts that if you can extend or enhance those timer or timing relationship, that indeed you can make the reuse the current radio interface with some modification, and then you can extend the cellular technology for the satellite use. And then by doing that, then we have chance that we for the vendor that can serve both.
Okay. I guess the other thing that we used was a standard cellular piece of infrastructure, which was the eNode B as well. So basically an unmodified eNode B from a partner company. the Institute for Information Industry, which is based in Taiwan. So we're basically using a standard eNodeB as part of this end-to-end setup using kind of 3GPP standards. So obviously you can see that on the diagram. So
yes,
what I was going to say, what did this actually prove? For us in Inmarsat, it actually proved that we can use a standard terrestrial NB-IoT chipset. We also identified the inputs that we needed to make into 3GPP for the work on non-terrestrial networks. So it provides a very practical input to the process of 3GPP for standardization. And it also proves that you can have a low cost or a very low cost path to a combined terrestrial and satellite IoT device. So using a single chip, you can switch between the two networks quite easily, and that basically means there's very low incremental cost because you're using the same chip. So if you were already had an NB-IoT terrestrial network, you can simply switch to satellite. So that's a very low incremental cost for your current path for IoT receivers and terminals. And from our point of view, we can also provide this service through our global network as well. So it proved that all of these things are possible. And that also then opens up a discussion about, is this for tracking, or can we use it for other applications as well? So right now, I think the IoT market is really focusing on some of the industrial applications. So industrial IoT, so such as logistics and tracking and transport and agriculture and those kinds of industrial IoT applications. But other directions that this could go in, it could go in the area of autonomous things. So whether it was autonomous flying things or things on the ground for tracking of those. And it can also go in the direction of consumer things as well. So putting messaging and tracking and safety services into consumer goods as well. So that all of the test actually opens up the possibility of all of these things being delivered with a standard and at great scale, on a global scale, and with a very economic route to market. So these are the applications that we envisage. I think the industrial one will be the one where we start, and then the other ones will develop later. What's going to happen next with this technology? So because we've proven this, and it's using technology that's coming from the MNO world, we believe that an MNO and a satellite cooperation is the best place to put some effort and to think about where we go next and find the sweet spot where MNOs and satellites can cooperate together and combine their networks. First of all, we fully support the work in release 17 in the study item for non-terrestrial networks in 3GPP. And that means that we will be moving towards dual mode IoT terminals, integrations between MNO and satellite networks, and using the same chipset for terrestrial and satellite NB-IoT applications. So for us, that means that there's an opportunity to expand the already massive terrestrial IoT opportunity to cover more areas, more applications, and combine with MNO networks to expand the already large IoT opportunity and also open it up to new applications that weren't already covered. We've noticed at the moment a lot of the IoT terrestrial discussions are mainly around urban IoT applications, and we don't see any reason why it shouldn't extend out to non-urban applications and non-urban areas. So that's where we think we're going to take it next. So that was kind of a very quick overview of what we did and what we proved and where we think we should be going next. So hopefully that was kind of clear.
Brilliant. Thank you very much. We will come back to you with some questions that are already coming in on the chat, but let me bring Thierry into this. Thierry, you are the 3GPP rapporteur for asset tracking. How is this trial relevant to the IoT over NTN study work that's ongoing within 3GPP?
Yes, as a bit outlined, so IoT by satellite is a huge opportunity. So to succeed and to address and to monetize this opportunity, you need an ecosystem that works. And an ecosystem that works means this is the right combination between the usage, the market, the use case, the technology, and the business model. So 3GPP, as most of you know, is the forum where telecom standardization is happening and where successful telecom ecosystems are made. By the way, this is also, because we didn't introduce Novamint, this is why Novamint is at 3GPP. We are a bit the interface between the verticals and the market and the telecom, and we help to develop standardized solution with involvement in 3GPP from SA1 to RAN. So standardized solutions that are combining the market requirement, the technology, and I would say the business model in an harmonious way. So in our view, this trial is extremely relevant for the IoT over NTN study because it shows that there are already solutions at hand for this topic. So now, if you want to make this a successful ecosystem and to be part of 3GPP, you need to reconcile all these possible technical solutions with the market needs and market expectation, which will allow proper and viable business model and benefits for all the players in the value chain.
Great, thank you. Thank you. So, look, obviously, cooperation is the name of the game here. Jonathan, why should an MNO be interested in NB-IoT over satellite? What's in it for them?
Yeah, we're actually talking to various MNOs about the applications, and we believe that we fill the lack of coverage in non-urban areas. So we think that if, for example, if you want to have something that's autonomous and flying and you're relying on terrestrial networks, you need to fill the gaps when it goes outside of an urban area or outside of a covered area to give you a seamless coverage. So if you can do that with a single standard and a single chip, then that makes it very possible and actually expands the usefulness of the IoT networks. So I think together with MNOs, we can expand the market for IoT in various areas, whether it's tracking of devices or whether it's some other consumer application. But just doing things in cities probably isn't an option long term. Right.
And what, I-Kang, can you comment on what markets you believe that satellite devices will be relevant to?
Yeah, I think like the title of this event, I think the tracker is the most interesting and attractive application to have this ubiquitous coverage, because as I mentioned earlier, this we cannot really put the cellular tower everywhere, and the machine or the cargo or the trucks, they can go to the place that the normal consumer will not really reach. So tracker should be the first market that could be directly benefited by this ubiquitous coverage. And of course, because we are using this a standard NB-IoT technology, so theoretically all existing NB-IoT application, as long as they have a coverage problem, they should also be benefited by this satellite link. And we are hoping that by bringing this to more like a consumer grade device, and we can also explore a new application and enable new market.
Great, okay. And Thierry, what's in it for 3GPP?
Need to. Yeah, so as mentioned just before, so 3GPP is really the right forum for this topic. And satellite needs 3GPP, but 3GPP needs also satellite. And as outlined by Jonathan and I-Kang, satellite is not really in competition with cellular. They are truly complementary. So with satellite adoption for IoT, but as well also there are another work on 5G in 3GPP, on 5G over NTN. 3GPP will be able to reach everywhere. It will allow to reach even more market with a truly global ecosystem, which is extremely appealing for the end customer. All the vertical, all the use case that I-Kang mentioned, including asset tracking. So all these use cases, they are already familiar with the 3GPP ecosystem. So it's extremely appealing. So the counterpart of course of this is that satellite industry needs to show commitment to 3GPP, to be there in the long run and to embrace fully this ecosystemic approach, and altogether cellular, satellite, and all the 3GPP members to build up a worldwide ecosystem, allowing everyone in the value chain to thrive. So with this assumption, I will dare then to say that what's in for 3GPP is that even sky will not be the limit anymore.
Good one. Okay, so look, I want to bring my own question into this. You know, we have, as a person on the street, I'm aware when I drive from Brussels to Amsterdam, we always drive past the port where we see containers on ships. I mean, transport of assets, of goods from one place on the planet to the other, be it by cargo plane, be it by ship, is something which has been there for many, many years. Why are these standards coming so late? Open question to whoever wants to take that one.
So I think there are already systems that are more proprietary that have come from various areas. So we already do lots of tracking of containers and trucks using previous standards, which are non-3GPP based standards for from satellites. So there already is quite a lot of tracking of cargo and trucks right now. But as the let's say the conveyor belt and of 3GPP and standardizations coming from the mobile world, you suddenly start to see that you can use the economies of scale that you get from using standardized technologies. You can also use those in the satellite world and move to things that will interoperate across more networks. So I think the reason you don't hear about it more and more things aren't happening automatically is because things haven't been standardized yet. And it's really quite difficult to integrate many networks of networks, and they tend to be non-standard networks. So you have all sorts of problems of integrating between the networks. So it's already used, but it's used in little islands of technology right now. So and that's where the mobile world comes in. Is the mobile world's been very good at standardizing and rolling out these technologies. So it gives you the opportunity to combine networks into networks of networks that work together and hand off and interoperate with each other.
Great. Okay. So I mean, the counter side of that question is, you know, standards have taken some time to get running. Now the work is happening. Does anything stand in the way of timely adoption of these standards? Is there a risk that we miss the boat? Thierry, maybe you can comment on that. Is there a risk that we miss the boat? What can we do to avoid missing it?
Yeah, I will answer this point probably in some extent your previous question. So again, it's a question of ecosystem. And a standardized ecosystem takes time to be developed. So probably there were plenty of solution already existing, but not combined all together. And to be developed, you need effectively more. So an ecosystem is not only technical. Again, I repeat maybe myself, it is the right combination between usage, technology, and business model. So there is already a market demand for IoT by satellite. So the market is really ready for adoption and ready to be grasped right now. There are some niche or some solution, proprietary solution that are going in this direction. And but basically technology is not standing in the way, as also demonstrated by this trial. And as you all know, 3GPP have the most brilliant technical minds all over the world. So no doubt they will deliver, they will provide a technical solution for whatever we want to do. Inmarsat and Mediatek demonstrated that this solution already exists. So the question is not technical, but the risk is to miss the boat, as you ask, is by, in some way, is by focusing already on the version 20 before to deliver the first version, especially with IoT, which is kind of simple, let's say simple type of device where you expect low complexity, but you want first, I want to address my first needs, its coverage. I want to be able to connect and to send in asset tracking, to send this everywhere from in the world. But at the same time, also version 1 of IoT by satellite needs to give already value. And if you are working on this in 3GPP, you need to give value to the 3GPP ecosystem and be enough appealing for significant market adoption. So the question is really how to deliver something that meets already the current market expectation and that will be viable for all players and in a timely fashion. So again, I believe that we believe that we will not miss the boat if we focus on the right mix between market usage demand, technology, and business model with this ecosystemic approach from the beginning, with the objective of allowing everyone in the value chain to thrive. That probably means, let's say, some form of prioritization or focus for the short term, while being able to prepare and to have the base and the step for the mid and the long term. And this, and probably this is also somewhere where a company like ours can help in this direction.
But so what are you saying? Because right now the work in 3GPP is study work. And if I understand well, the pace at which it's going, when will we see the normative work items in this subject coming up? Will that be still in release 17 or will that only be for release 18? Is that relevant?
Yeah, as I said, it's again, you have to consider what you want to achieve in I would say in the short term, or what is the market demands. If you arrive after the market demand and you have done the most brilliant study and then the most brilliant standard, but the market has already adopted something else, everyone is losing there. So you have to really focus on a form of prioritization, but with and short term, but still enabling the mid and long term, while but you need to be driven by the market. What do I need? What the market can live demands now? How can I serve it already now? And also how I can have a viable solution that will give value to the 3GPP. So there is a way to do that, but it's a kind of prioritization and focus on when and what value I bring to the market to give the most chance or the highest chance for 3GPP adoption.
Got it.
At all the stage, short, mid, long term.
Understood. So we actually have some questions which are relevant to the market side of it. So let's come to those. I-Kang, can you comment on the potential cost of satellite NB-IoT devices? Would it be similar to terrestrial?
Yes, I think I'm not really able to comment the cost because right now we only do this kind of like a trial. But just in terms of the complexity, put it in that way, based on the experiment, we don't really see that is a issue.
Great.
So hope
Okay.
that can address the question.
All right. Does anybody else want to make a comment on that one, or?
I'll just comment that we didn't change anything in the standard chipset for the trial. We changed the firmware to compensate for satellite delay and a little bit of Doppler effect, but that was changed in the firmware. But basically everything else was standard from a chipset point of view.
So I mean, that's actually pretty fundamental to cost, right, Jonathan? I mean, if you're using existing terrestrial chipsets, existing satellite systems, and you're only having to compensate for one thing, is that directly related to the cost implications?
Yeah, the complexity of the silicon didn't go up from my point of view. We reprogrammed a few things, so that is kind of the key for me, is that you start to use standard technologies across more than one network. So yes, but because it's a commercial decision, which is kind of for Mediatek to take, I'm kind of hesitating to kind of absolutely say something, but just give you an indication of what we didn't change, the lack of change in the test. So that for us was very important.
Right, so that's a wait and see then. But staying with the market, when will devices with NB-IoT chipsets adapted for satellite become available on the market? Who wants to take that?
Yeah, so we have already seen some companies using NB-IoT unmodified in the market in other networks, so not related to this test or even our company. So it just proves that you can use current NB-IoT chipsets over satellite already. And it really depends on if you want to wait for things to be very formalized, or whether you want to try and do something ad hoc using the current terrestrial standards that are there. So you could go out and do something, but you might run the risk of not being completely standard as the standard moves on.
Right.
I don't know if that answers the question. So and then obviously as the standardization works on, you become more confident in moving forward.
Yeah, indeed. And I think relevant to also to the timeline for all of this is the fact that we see there's a lot of interest from NGSO systems in IoT. There's a lot of startups that are emerging wanting to address this market. But what you have shown with your trial is that Geo can already do it today and just compensate for one matter, being the time, being the latency, right?
Yeah, non-geostationary satellites have to add another layer of complexity related to handoffs between satellites moving and the large Doppler shift that they have as well. So I mean, I'm sure over time those will be compensated, but that's another layer of complexity that you have to add. So for low bit rates and simple messaging, and for getting started, the quickest route to market is definitely with geostationary, because you don't have those added complexities of handoffs and Doppler.
Okay. Another question we have is, can the NB-IoT devices produced by Mediatek be used by other satellite operators, for example, Thuraya in L-band?
I think assuming we have a standardization solution, the standard will ensure the interoperability. And that should allow, I think, not just Mediatek, but every vendor, if they just follow the standard, they should be interoperable. Yeah, just put it in that way.
Yeah, your comment reminds me of Adrian's Grace always making the point to me that 3GPP defines standards which are spectrum agnostic. So the band, in theory, shouldn't really matter. Okay, next question is, would compatible devices with Inmarsat satellites still be small, autonomous, and low power? And what impact on costs and lifetime?
Yes, small. I mean, we used the standard reference boards from our friends at Mediatek. The antennas were low cost. What was the other one? Impact. Oh, and the power as well. Yeah. So the power consumption of the standard and the amount of power that we had to put in there wasn't significantly different from the terrestrial standards as well. So it's in the same region as the terrestrial system. So I wouldn't expect to see anything in a an end device. So if you've already seen NB-IoT devices from the terrestrial world, they'll be very similar. I think the one additional cost, there may be some additional cost for a slightly different antenna and some slightly different tuning, because the L-band frequencies tend to be slightly above the terrestrial frequencies.
Right. And also, what impact on costs and lifetime, they're asking?
Lifetime compared to what? I think the lifetime of an IoT device is really probably determined by the manufacturer of the electronics. So I don't see it as any different from a terrestrial IoT device.
Okay. So does anybody else want to come in on any of the questions that we have tackled so far? Thierry, do you want to comment on anything? You're on mute, Thierry. Thierry, can you unmute yourself, please? There you are.
Yeah, so I unmute myself, but you mute me. Yes, I was saying that the question that I ask are at the edge of the technology. Of course, they are technology. They are questions that have an impact on technology, but in fact, they are questions expressed by the market. If you are talking about low power, this is the market demand in an asset tracking, the life of your asset and what is the battery that you put in, and how long your device will last is maybe the most critical point, because this is the whole business model of asset tracking. For example, for container tracking, you need to be sure that this business model is sustainable by the companies that are doing container shipping. So this is where we are at the edge of the technology, and this is where the market, the requirement specifically on low power should come from the use case, from the use. And this is where you reconcile, do I have a technical solution? Yes, but it doesn't matter if my device dies 1 month after I launch it. There will be no market adoption. So you need to have ready this matrix. What is the market demand? What is the technology that could sustain this market demand, and what is the business model that works and that is viable for all players, including and most importantly by the market. So the question of low power and the question of lifetime is probably the most critical question, and this is where it should drive the work, for example, in IoT over NTN study, and we cannot just accept, let's say, a question, an answer that is it's similar as cellular. We need really to demonstrate that the technology meet the market expectation. But with this, if you have really this focus, you have a tremendous value and easy market adoption.
Got it. Okay. So a couple more questions. I think they're probably for you, Jonathan. Will this require a clean line of sight towards the satellite to work? And is the trial based on bent pipe?
Yeah, so in general, clear line of sight is best, but actually in this trial, even using a low-cost antenna, we did manage to get reception indoors. So it's it depends on the antenna specification and the power that you're putting in and out of the satellite and in and out of the board. So actually in the POC, we did get some indoor reception as well. So yeah, and it's a bit, it depends. So it depends on exactly where you settle the specification in terms of power and antenna specifications. But then also if you're using it in conjunction with an MNO network, then you also have the MNO network as well there as well. And then bent pipe, I assume that means, is the satellite kind of transparent to everything else that's going on there? So yes, for us, in terms of the satellite, it was about the bandwidth allocation and the power that we were allocating to that. So yes, it was relatively transparent to the satellite itself. So we had a standardized E node B and we had a standardized chip at the other end. And then we allocated power and bandwidth as we felt necessary and made the measurements of the performance based on certain power and certain bandwidth.
Okay. And how do you see the growth of other IoT technology from the satellite perspectives, such as LoRa and Sigfox, as compared to standardized IoT?
Oh, right. Yeah, I mean, my view is possibly a little out of line with most people's comment on this. I view LoRa and Sigfox and some of the other low power WAN standards as in addition to satellites. So for example, we have Sigfox implementations where we have satellite gateways that then connect to LoRa or Sigfox networks. So I see them acting as a low power WAN in a local area, whereas satellite-based NB-IoT is really a direct-to-satellite global network, which doesn't really have need for that. So if you want to aggregate lots of local sensors, I think LoRa and Sigfox are really great standards for that. Which one proves most popular, or whether it comes from something that's like a Bluetooth standard, which one wins out, I don't really know. You could also use Wi-Fi in those areas as well, developments in Wi-Fi. So I view them as addressing a slightly different configuration. So I personally, I don't see them as a, let's say, competitive for direct-to-satellite IoT for things like tracking.
Okay. And is there enough radio spectrum available for satellite IoT applications? Are you able to comment on that, Jonathan?
It depends on the scale of the application, and it depends where it is. So yeah, I think all I can say on that is it depends. What I would point out is that IoT is a messaging system. It's relatively low bit rate. If you're going to read a smart meter, maybe you only need to do it once a month. Maybe you don't want to do it every second. Yeah. So some of these applications are a very low data rate. So it's really about the coverage and the ubiquity of it in satellite, in NB-IoT. It's less about kind of the total data rate. So we're expecting that there is the right kind of radio spectrum, but again, you have to take it case by case.
Exactly. I mean, on the one hand, the devices are not saying that much, but you need to balance that with the fact that the market forecasts for this sector are, we're talking about billions and trillions of devices even, right?
Yeah, and that's why I think the important part here is actually the combination of the networks as well.
Okay, and actually related to that, we've just had the latest question in, which is IoT needs large connections. How could satellite solve the capacity problem? Narrowband, but large connections.
Oh, about the scalability, basically. Yeah, we definitely need to address that scalability, but I think that was one of the design criteria in 3GPP, is that NB-IoT should be both low power and large scale. So if we're going down that standardized route, that should be addressed in the standards.
Okay.
And
great.
that was one of the stated objectives.
Okay, so let's come back to the market for a second. I mean, Thierry, in your capacity as Novamint, obviously you're closer to the client. We know that there are huge risks associated with transporting goods from one continent to the next, and some of us have heard about disasters. Last year there was a disaster that led to 283 containers being lost in the North Sea. I think 43 of them are still missing, and 2 of them had hazardous contents in them. Surely the market is crying out for these solutions and standardized solutions that can be scaled up. Is that your experience? What is your feedback from the market, and what do we need to do to bridge the gap? Thierry, you're on mute.
Okay. Yes, there is, as I mentioned before, there is a huge market demand, and so far they have been, let's say, scared, or they have not met the right solution for their needs. They all look into satellite. There are still the fear that satellite is too expensive and may be a bit too complex, but the IoT development, including what as an answer to the question before, there is this emergence of, there were this emergence before NB-IoT of Sigfox and LoRa. So this low power type of technology have shown that there is that you can do low power type of IoT, to very simple, low complexity, then NB-IoT develop, but at the same time, the demand for ubiquity, for worldwide coverage start to increase, and already market are looking into solution. How do I transform my LoRa, my Sigfox with a satellite offer, and still with this low complexity, low cost type of device. So it is, again, it's not technical. It's not a technical issue, and it's really, there is a market demand. You have just to grasp it and basically be ready for them at the right time. And again, what transpires from this is the market is there. So deliver your V1, your first version, give value, show that 3GPP is the right ecosystem, and that it will grow even further, and everyone will embrace this this truly global ecosystem.
Got it. Okay. And what more can ESOA do, or how can we increase the satellite industry participation in 3GPP? It's clear that the voice there needs to be loud and clear from the satellite sector. How do you think, you all of you participate in 3GPP? What's your take on that? How do you think it's going? Do you think we need to do more?
So from our point of view, we both follow and we partner from a 3GP point of view. So we support it, and then we also work with our partners to support them with the information that they need. So, for example, working with Mediatek is good for us because they obviously know the mobile phone world very well, but they needed some kind of hard, concrete facts to progress the satellite angle as well. So we're partnering with key people. But yeah, I think the satellite world could spend some more time doing that, but I think compared to the mobile world, is that the satellite operators are relatively small. So you will always see more of the giant mobile operators there and some of the equipment manufacturers there, rather than seeing lots of satellite people. So I think clever partnering and working with partners to incorporate satellite into the 3GPP world is probably what's going to be necessary.
Right, okay. I've received another message, which is NB-IoT being based on log-on plus resources allocation, which can be a problem for limited resources in NTN. Can we imagine useful messages sent directly in the login message for the applications that need less bandwidth? Slightly technical there, I'm afraid. Me?
I don't know if you wanted to comment on that, I-Kang. I don't think
I can try.
Yeah.
I didn't really see the question on the chat room, but I try to answer. I think it depends on which system you compare. Just you go back from the physics perspective, transmitting 1 bit, how much energy and how much radio resource you need to consume. The fundamental theory is there's no much difference. The main difference comes from the how efficient your system is designed, but that should not give too much difference. I also see some question regarding the capacity. And then, of course, if you compare with like a terrestrial network, and which have like a much smaller cell radius, and of course you can get one capacity. But if you consider the NTN, and you probably need to compare with the existing satellite system, and because of those fundamental physics, and there should not be too much difference. So I hope that could also answer the question to some extent.
Brilliant. We have a few minutes left, so if anybody else wants to ask a question, please post it in the chat. And let me ask each of you to comment on something. If we fast forward 10 years, what does mobile IoT look like? Who wants to go first?
Yeah, for me, it would be IoT is tracking just about everything that you can think of. So it's tracking planes and trucks and boats, containers and deliveries, and the software platforms that will be piggybacking their business on the networks will have figured out how to track things across the different modes of transport. So I think people call that multimodal. That's actually a very difficult thing to crack. So I think the software industry will start in kind of little pools in maritime and on land and on air, but eventually they'll figure out exactly how to do just-in-time delivery and tracking based on IoT. So I think that will happen. And then you will also see the technology start to be built into consumer goods as well. So then you'll start to have consumer propositions for both tracking, messaging, and voice. And I think mobile and satellite networks, consumers actually won't notice the difference between those networks. I mean, there obviously are different different characteristics of satellite. You know, some of the line of sight things and some of the bandwidth issues are slightly different to the terrestrial world. But I think you'll see those even in the consumer world, those things beginning to merge as well.
Okay, thank you. I-Kang?
Yeah, sure. Yeah, I think today we already have a satellite IoT technology, and we also have like mobile IoT technology by the cellular operator today. And but we can see that still around the world there is many people, and there's a large portion of the area are not well connected. So we are envisioning hopefully in the future, we keep growing this mobile IoT to like more penetration and to more country, especially not just on, we should probably redefine so-called IoT. That is not just happen in like a factory or some like a very particular use case. We hope that could be more affordable, and we hope that could be more available to the consumer space. That because it's always when you go to the consumer space, then all the people around the world, they will always invent a new application that will further stimulate the market. But we need to bring that to the make it available and affordable. So that is a hope that we hope the mobile IoT could grow. So that is why we believe this integration of the cellular and this satellite network is a very important step to really offer this global coverage.
Thanks, I-Kang. Thierry?
Yeah, as I said just a bit before, sky will not be the limit anymore. So with the addition of satellite and probably some other capabilities, fast forwarding in 10 years. So mobile IoT will be the only true global, and I will insist on that, and secure standard meeting this promise of hundreds of billion and more massive IoT deployed and adopted by all markets. So it will be everywhere, and basically, effectively, for vertical, probably also for consumer, and I insist on the word secure also, because we should not forget the huge value that in a cellular device that you have with the SIM card. And the SIM card is also can provide a strong secure element, because also the key in the future for IoT is also security. And if you have an asset like the SIM card coming inherited from this 3GPP cellular ecosystem, you have again a huge value, still with a very low cost, low complex device. You can reach everywhere, be truly global, and still much secure than most, if not all, the proprietary solution.
Got it. Thank you. We have one last question, and then we'll close after that. Can we imagine that satellite IoT may be part of domotic applications in the future? Who wants to take that?
I would say, I think the objective here is to make sure that from a end user point of view is that you don't notice the network. So if you have a single device that can switch between networks, maybe you can switch between terrestrial networks and satellite networks in a domestic setting. I think it really depends on the application, where the device is. So like your mobile phone, if it switches from say a 3G network to a 4G network to a 5G network, in general, you don't notice. So if you're also including in an IoT device another network, you probably wouldn't notice. So exactly which kind of home applications, I'm not quite sure how to answer it, because I'm not quite sure what the applications might be. If it was meter reading, most houses will probably be in urban areas, so it'd probably most of the time go through a terrestrial network, but maybe in some places you'd actually just simply switch to satellite as well, so you probably wouldn't notice. So that was kind of the objective of kind of mixing the two networks.
Okay, great. Well, I want to thank everybody for participating. Please stay tuned for our next events. I want to thank our speakers for having taken the time to present to us today and to chat with us and answer all the questions. I'm going to ask our speakers to stay on so that we can take a closing photo. But please, participants, thank you so much for joining. Please follow us on Twitter and LinkedIn, subscribe to our newsletter and our YouTube channel. And we will look forward to seeing you at our next event, which is going to be in December. Thanks, everybody. Thanks for joining.